Touch the leg, everybody, and welcome back to yet another video lesson. Well, as of today, I have decided to be up on the desktop, and the reason is we have technically come to the end of the chapter, namely data structures, and I wanted to solve some questions which are generally exam oriented, and then I found a few questions which are very interesting at the end of your textbook. So I thought why not cover up those few questions which are extremely important from the examination point of view. And then there were a couple of questions which are really very interesting, and I'm sure if you could have a firm idea regarding the solutions of those problems, it will for sure enrich your programming knowledge. So I have listed 6 questions. The first one is writing a program to implement a stack. Over the last few classes, I've explained to you the working of the stack, the working of the queue. I took the help of the whiteboard and the marker, with which I have more flexibility. I could explain in a more convincing way with the help of drawings and diagrams. So that's one important aspect. But now the next important aspect is, especially for those students who do not have computers at home, if you could see the live working of these programs, it will serve you a greater good. And then these questions are a little different. There were some minor changes to the questions. So not only you'll be able to see the live working of these programs, but along with, you will get to be familiar with the questions which have some kind of little additions or twist. So this will definitely help you to prepare better for the examination. So without any further ado, let's get started. So we'll start with the first question. Write a program to implement a stack for these book details, book number and the book name. That is, now each item node of the stack contains 2 types of information, a book number and its name. Just implement push, pop and display operations. So this is one full-fledged question on the implementation of the stack. One thing to be noted is it's super important to read the question very, very properly. Many of us, especially 12 students, are not too patient enough to go through the questions in detail. So that's a big mistake. So today I'll be doing it live up on the Python IDLE, and then since we have already learned the working of these programs, we should not take much of time to finish up the program, but in between I will surely come up with the explanation here and there. So let's get started. So this is the question number 1. So I'll be writing the code here, just make some spaces. Okay, so first things first, we'll come up with the main menu as usual, right? So before I come up with the main menu, we have 2 important variables, one for the list and one for the top variable. So let's say the name of the list is stack, and then initially it should be an empty list, and then the top variable should be initialized with a value of none. So since the stack is empty, the value of top should not be pointing to any index as such. Hence, the value of top should be initialized to none. All right. And then we'll run this while loop, true, and then we'll come up with a menu, right? So print, and then in order to make the output little better, I would like to add some lines. Okay, and then the next up is the heading should be stack operations, right? And then again I'll have the lines. Okay, once I'm finished with this, it's now time to write the menu items. One dot push, number 1 for the push, and then number 2 for the pop, and then number 3 is for the display of the stack status, and then finally we'll have one option of 4 to exit the program. Alright, so these are very much familiar to you. Okay, now it's time to prompt the user for the choice. Alright, so ch equals int input and then enter the choice. This will be the message prompted to the user. Alright, so if the value of ch is equal to 1, we'll have to call the function of push. But before that, we need to receive the item, and this time the item contains the book number and the book name. Alright, so in the earlier example, we have just simplified the program, which meant using just one integer variable for the item. But as of today's question, the item should be containing two important the items. The first one is the book number, and then you have the book name. Alright, so BNO for the book number, and then input. Okay, I'll just have a message of book number. Alright, and then once I'm done with this, just get rid of this. Okay, and then you have the B name for the book name. So since it has to be in the string, we don't need the int. Book name equals, alright, and then I close the bracket. So let's prepare the list. Let's prepare the first element, which will be in the form of list. So this time we are going to have a big list, and then the individual elements are again going to be a list where you will have two elements. The first one is book number, and then you have the book name. Alright, so item equals, the first element will be BNO, and then you will have the B name. Right, so let's now call the function of push and then send two arguments. The first one is stack, and then the second one is the element or the item to be appended to the stack of stack, right, which is stack itself. Okay, now let's go up and then let's define the function for push. Alright, but before this, I'll write the definition for the function of isEmpty, which I'll be using in the pop, since we don't have the peek function here. So the pop needs this. Yes, you could do away with isEmpty, but the idea is to learn some additional ways via which you could accomplish or which you could write the program. And then let's receive the stack as stk, and then if stk is equal to empty list, then I'll be returning a boolean value of true. Else let's return the boolean value of false. Right, so this is the function definition for isEmpty. Now the next up is you have the function definition for push. Right, so let's have two receiving arguments. The first one is stk, and then you have the item. All right, okay, so now the body of the push should have the append function. Right, so this is simple and straight. stk dot let's use the function of append to add the element onto the stack, namely stk. So you will have append and then item. All right, and then once the first element gets pushed onto the stack, let's update the value of the top. The top variable should be pointing to the first element. And then if you could recall correctly, the value of top will always be equal to length of stk minus 1. So once the first element has been appended, the length of STK will be 1. 1 minus 1 will be 0. So top will be pointing to the first element with the index of 0. So this statement is very important. The value of top is always equal to the length of STK minus 1, right? So the push function is pretty simple. So now the next step is, let's go for the second choice. The second choice is LFCH is equal to 2. If the choice entered is equal to 2, which means we would like to pop an element of the stack, right? So item is equal to pop. So you need to be careful. This big POP is a user-defined function. So be careful. You're not supposed to have small p, which means small POP is a built-in function, alright? But we would like to have our own function defined. Hence, change the small p to big P, and then I'll have to send, the list, namely stack. And then, however, from the function definition of pop, just in case if you receive the item value is equal to underflow, alright, then let's print a message saying the stack is empty. It's a underflow situation. So which means you cannot pop any element as such from the list, alright. However, if this condition is 2 equal to sign, right, be careful, and then you have else. If the value of item is not equal to underflow, then we'll print the popped element. So it's going to be like popped element is equal to the value of item, alright. And then let's go up, we'll just save the file, and then let's go up and then write the function definition for pop. So def, be careful, it has to be big P OP. The function call has to match with the function definition, and then the stack as a list will be received as STK. And then before you pop any operation, we need to check whether the list is empty or not. If so, the situation is called underflow. So let's use the function of isEmpty to check whether the STK is indeed empty or not. So for this, let's call the function called isEmpty and then send the argument of STK. Alright, so this function will be called, and then if the value of STK is equal to empty list, the true boolean value will be returned. If it's true, then return a message of underflow. Alright, make sure that you get the spelling right. And then up next is else. If it's not empty, then which means we could actually pop an element of the list. So you'll have to use the function of pop, right? So item equals stk dot pop. Okay, and then if the last element, if the last element is the only element left in the stack which when popped, which means we need to check whether the list is empty or not. Alright, so you can actually check it like this. Okay, and then once the item or the element has been popped, this condition will be true if there is just one element left in the stack. So if the condition is true, then we need to update the value of top. Alright, top should be equal to none. Alright, so however, if that is not the case, if it's not empty, then top is equal to the length of stk minus 1. Okay, so and then finally we could just return the value of item. Alright, so I hope you're clear with this. Initially check if it's empty or not. If it's empty, return underflow, and then that's the end of the function definition. If it's not empty, pop that element and then have it assigned to item. And after popping, if the stack is empty, which will be true, if there is just one element in the stack. If this condition is true, then the value of top should be assigned with none value. Otherwise, the value of top will be updated to length of stk minus 1, and then finally you can return the value of item back to the main function, right? So this is quite simple. And then let's save it. Okay, and then finally, as per the question, the third option is for display the status of the stack with each push, with each pop. If you would like to check the status of the stack, you'll have to go for the third option. If the value of ch is equal to 3, then let's call the function of display, but we need to send the argument of stack. All right, and then we'll finish off the remaining the option lf ch is equal to 4. Then I would like to come out of the while block. All right, so this is self-explanatory. And then let's go and complete the function definition for the display. All right, def display. Okay, and then let's receive the stack in stk. Okay, and then now the value of top, we'll just find out the value of top. The value of top, like I said, will always be length of stack minus 1. Okay, and then let's print. But before we display, let's check whether the list is empty or not. Okay, otherwise, if the list is empty, you should be printing the message saying the stack is empty. So if the length of stk, so this is another way to check whether the list is empty or not, right? So length of stk, if it's equal to 0, then print the stack is empty. That should be more than enough, right? Else, if it's not empty, then we'll print the topmost element first. So print, and then stk, you have the top. All right, okay, and then followed by, we'll just have an arrow sign indicating that it is the topmost element of the stack. Okay, something like this. That should be enough. So with this, I could print the topmost element, stk of top. The top, has the index value of the topmost element for sure. Okay, so now it's time to print the remaining the elements, till the bottommost, the element, right? So let's use the for loop. For I in range, okay, it has to start from the second topmost, so which means it has to be top minus 1. I printed the topmost element. Now in the for loop, I need to start with the second topmost element, and then you need to continue till 0, right? So if I write minus 1 will not be included, remember? So the for loop, the value of I will reach the last value as 0, and then it should be updated as minus 1. I need to keep reducing or decrementing the values of the index which starts from the top, and then you should make your way down the index. Okay, and then now just print it. Print, and then how do you print it? This stk is the name of the list, and then we'll have to use the variable of I to indicate to the individual the indexes. All right, okay, like this, and then that's it, I guess. So this is how you print the remaining elements, one by one. All right, so I guess that is all. We are done with 3 functions. The first one is push, the pop, display, and then stack. Top, you have the while body, and then you have all the options one by one. So let's run and check. Hopefully I've not made any mistakes, but even if I have made some mistakes, it gives us a wonderful opportunity to debug the error. All right, so let's get started. Okay, it starts from here, so I'll go to run, and then F5. Okay, it looks good, but you never know. I need to check all the options. Okay, so we'll start with, I want everybody to focus on the output. All right, so we'll start with choice number 1. Book number, say 100. Press enter. Book name, my favorite book by His Holiness Beyond Religion. Right. Okay, let's do it 2 more. Enter choice 1, okay, for the push, and then book number 101, and then the Book of Joy, okay, the Book of Joy, and then press enter. Let's push 1 more. I hope you're able to see this, or I'll just get this little up. Oops. Okay, this is better, I guess. Okay, let's push 1 more book, say option number 1, and then 102, book name, another book, the Essence of Heart Sutra, the book which I'm currently reading now. Okay, press enter. Okay, we have pushed 3 items, and in each of those items we have the book number and the book name. All right, so let's display. So for display, I need to press number 3. All right, so when I press enter, you could clearly see the right answers. As you can see here, the moment I enter the option number 3, I see the topmost element, okay, which was the last item that has been entered. All right, so, and then you have the second last, okay, and then this is the first one that I've pushed. All right, so this is the first one that I've pushed, followed by this, and then finally I have pushed 102, the Essence of Heart Sutra. Hence, the top variable points to the last the item. All right, so this the manner of pushing, popping is actually called as last in, first out. So when you start to pop, the first one that got in will be the last one that will be out of the stack. Okay, so this will be the last in, this is the last in, okay, sorry, this is the last in, sorry, this is the last that got into, which will be the first one that will get off the stack. So last in, first out. Okay, so last in, first out, LIFO is the data structure which is adopted by the stack. All right, we have already learned all these the mechanisms in great depth, so let's not spend much of time. So I could pretty much say that the push and the display functions are working without any problem. Let's try the pop. For pop, it's number 2. So when you press enter, as you could see, the popped element is equal to 102, the Essence of Heart Sutra. Remember, the Essence of Heart Sutra is the last element that got into the stack. So the moment I pop it, it is the first one, that gets off the stack. All right. So once I pop this and then check, the status of the stack. Let's check how the status, the stack looks like. So for that, I need to I need to press number 3, and then as you could, see, now this time the Essence of Heart Sutra has already got off the stack. Hence, the Book of Joy 101 becomes the top element. All right, so this is how the stack gets updated, and then we'll pop 1 more. Okay, so number 2. So when I do this, the popped element, the Book of Joy, has been popped. Let's display number 3. There should be just 1 element. All right, so we'll pop that also. So number 2. Okay, now when I do this, the last element gets off the stack. So you try to pop again. Okay, number 2, you should get the message of stack is empty under flow. And then even if you try to display, you will get the message as stack is empty, right? So now with this, you should be able to have a complete picture of how, the stack could be implemented with regard to storing informations like, the book number and the book name. All right. Now it's a complete picture. Weeks back, we have learned on the whiteboard how, the stack could be implemented, how stack as a data structure could be understood with the drawings and, the diagrams. So that's really important to start with, but this is equally important to end with. All right. So now let's move on to the second question. The second question is, let me check the time. Okay. Now the second question is, okay, let's get this a little up. Okay. Now the second question is with regard to the implementation of queue. All right. So write a program to perform insert and delete operations on a queue containing members' details as given. Member number, member name, and then you have the age. All right. So let's do it. So again, this should be pretty simple. Hence, we have already learned it. Now to start with, we need the variable like the front and the rear. So to start with, we'll have none value assigned to front. So in some of the textbook, you may see -1 being assigned to front. So that should be okay. So you assign none or -1, it's pretty much the same because the index generally starts with 0. All right. And then now this time, we'll have a list by the name of Q. All right. So again, that should be empty. So this is nothing but a stack. All right. Sorry, this is nothing but a list. So we are basically implementing the data structure of stack and queue via a list. All right. So that's about it. And then now let's come up with the menu, right? So again, you have this while loop. Okay. And then to start with, what do you have? Okay, you have this print. I love to get these lines. So let me. All right. And then you have the print followed by queue operations. Okay. And then we can just have the lines again. That will make the output look better so that you'll be able to understand better. Okay. Let's get this. Okay. Now after this, we have the menu items, right? So print, the number 1 is for the NQ, right? So which means, this menu item is for the insertion. Okay. And then now the next up is you have the DQ, right? Number 2 is equal to DQ. And then finally, we'll have the display, right? So we just have the insertion and the deletion. So if, there's a question with regard to pick, you should have that option included as well. So number 3 is NQ, DQ, and then you have the display menu item. And then finally, there should be an option to come out of the program, right? We didn't come out, right? Did we? So we'll just come out of this. Okay, good. And then just change this. Okay. Now it's time to come up with, the choice. So let's accept the choice int input, enter the choice. All right. Enter the choice and then should have one additional bracket. And then if ch is equal to 1, so that's for the NQ or the insertion, right? So if this is the case, if the value entered is equal to 1, then it's time to receive or prompt the user for the data like member number, member name, and integer, right? So I'll just write here mem number is equal to, since it's an integer, input member number is equal to, okay, and then mem name is equal to input member name, right? Okay, sorry. Okay, and then mem age should be the third data, so that's again an integer. So input member age. Okay, once I'm done with this, it's now time to make the list out of these three data, or these three elements. So let's have the square bracket. The first one is mem number. Be careful with the spelling. Name, and then you have the mem age, member's age. All right, I'll be careful. I'll try not to make mistakes. Okay, now let's call the function of q. Right, so the name of the function is insert. All right, so let's call the function of insert q. So this is the name of the function, and then okay, that should be fine. Insert q. Okay, and then we'll send the q list. All right, so this is the main list in which we are going to add or enqueue or insert all the elements one by one, and then we'll send the item to be added. All right, so let's go up and then write the function definition for insert q. But before this, we'll have the is empty function to check whether the q is empty or not. All right, so let's receive the q as q, and then let's write the statement to check whether the q is empty or not. So these are pretty much the same. If it's empty, return true, otherwise return false. Okay, so this is exactly similar to the one which we had in the stack program. Okay, and then it's now time to write the function definition for the insert q. Right, so def insert q, let's receive the q as q, and then item as item. All right, so again, in a queue, just like in the stack, the new element or the new item will be inserted at the end. So the moment you have your focus on queue, imagine the lines or the queues we see in front of the ATM, the kiosk. All right, so the new person gets added at the end. So the append function does that exactly. So you can use the append function. So q dot append. All right, be careful of the spelling, append, and then I could just write here item. So the way it's being added in queue, the way it's being added in stack is exactly the same. So that's the reason why we are using the append function in both. So after this, you need to check if the item is the first item that gets into the queue. So for this, how do you check is if the length of queue is equal to 1. So what do you mean if this condition is true? If this condition is true, if the length of queue is equal to 1, then it means the item that we just added is the first item that is being added onto the queue. So if that is the situation, then the value of front and the value of rear should be updated with a value of 0. Okay, so I hope you're clear with this. If the item that is being inserted is the first the element or the item, the front and the rear, both should be pointing to the first element, and then as obvious, the first element's index will always have the value of 0. Right, so otherwise, okay, so if this is the case, the value of front and rear should be equated with 0. Okay, so that's pretty much. And then otherwise, if you could add it, it shouldn't be a problem. The rear value, right, the rear value, if that's not the case, the value of rear will be the length of q, and then you have minus 1. Okay, so the rear will be pointing to the length of q minus 1. I've already explained. All right, so with this we are done with the function definition for insert q. Right, hopefully I've not made any mistakes as such. Okay, now let's go to the second option. The second option is LFCH is equal to 2, and then you have item is equal to, now this time the name of the function is delete, right? So delete q, this is the function call, and then we need to send the stack, namely q. And then as in the stack, if item is equal to the underflow, okay, if this is the situation, then you should be printing a message saying q is empty, so you have a situation of underflow. All right, otherwise if the condition is false, then you should be printing a message. Perhaps it could be something like a deleted item is, okay, the item. All right, or you could have the message like dequeued, okay, or the removed. That shouldn't make much of difference. All right, now let's go up and write the function definition for the delete q. Okay, so we have def and then delete q, and then let's receive the q in q, and then check whether the q is empty or not. If it's empty, we'll return a message or string value of underflow. Right, and then otherwise else. Now we need to get rid of, right? So this is important. In q, how do you remove the element? Should you remove the element from the rear end or from the front end? Understandably, when people wait in a queue, the first one that stands in a line, should be the first one, that gets off the line. Okay, so which means, I need to pop, but I need to pop from the front end. So the front, the most element index is always 0. All right, so you could have the statement like this: q dot pop, and then this is important, 0. So q dot pop 0 means the element with the index of 0 will be popped off the queue. So the foremost or the frontmost element or the item has the index value of 0. Hence, that will be the element, that gets off the queue. All right. So when you do this, now there could be a situation like, say you just have only one. You just have only one element in the queue. All right. So if that gets off, then the value of front. So I need to check again if after popping, if q is equal to empty, or you can have if the length of q, either ways, it's all right, if it's equal to 0. So if that lone element has been popped off, this condition will be true. If that's true, then the front and rear value should be assigned with none. So the front and the rear, they should not be pointing to any elements because the queue has now been emptied. All right. So I hope you are okay with this. Now, finally, let's go for the display choice. Okay. So press enter, and then LF choice is equal to 3. Okay, choice is equal to 3, and then let's straight away call the function with the argument of q. All right, be careful of the spelling. And then finally, if the choice is equal to 4, then we need to have the break statement to leave the loop. All right, let's save it, and then I don't need all these, right? Okay, where am I? Okay, just get rid of all these. I'll just have this converted to the first question. I'll just have this converted to the comments. All right, 1, 2, 3. triple quotes is used to set the comments in multiple lines. So till this point, okay, let's change the program number 1 to comments. All right, so triple double quotes, or I guess triple single quotes, is used to make multi-lines into comments. Okay, so where are we? Now it's time for the function definition for the display. So def, and then display, let's receive the Q in Q, okay, like this. All right, let's make some space. Okay, first things first, the value of front, should be set to 0. All right, and the value of rear will always be equal to length of stk minus 1. So, these are standards ways to find out the standard way of finding the value for rear. Okay, but the queue could be empty, right? So just in case, if the queue is empty, I cannot proceed any further with the display. So hence, display this message. Sorry, what's happening with me? So this is queue. Okay, I hope I have not made the same mistakes anywhere. Okay, looks good. Okay, so print the queue is empty. Okay, else elif, but if there is just one element in the queue, then the front and the rear should both be pointing to that lone element in the queue. So that could be another variation in the display of the content of the queue. So if the length of queue is equal to 1, which means there is just one element left in the queue. So if that's the case, then I would like to print that element, okay, that element with the mark aside as something like this. This is the front, okay, this is the front as well as the rear. You just have only one element, so which means that element becomes the front as well as it becomes the rear element, right? So this is just another variation for the displaying of content of the queue. Okay, if both the conditions are false, then I now need to start with the front first. Okay, I need to start with the front and then move on with the rear. All right, so print, how do you print the first, the element S? I could perhaps do it like this. Say print, the name of the list is Q, and then you could just write front. All right, Q of front means Q of 0. Okay, and then I'll have the pointer, saying this is the front element. Okay, this is the front element, and then it's now time to print the in-between elements, between the front and the rear, for which I'll be using the loop. So for I in range, okay, I now need to start from front plus 1. Since I'm done with the front, the frontmost element, okay, I now need to start with the second element. So which means I'll have to use front plus 1 and then continue till rear, okay, or perhaps, just to make the coding simpler, I can have 1. 0 always refers to the first one, 1 always refers to the second. So it's okay if you start from the number 1 and then continue till rear, okay, and then that's it, I guess, for I in range 1 comma rear, and then print, I want to print the remaining, the in-between elements, right? So Q, and then you have the I. All right, okay, once I'm done with this, once I come out of the loop, I'll be printing the elements with a value of I from 1 till rear minus 1, because the rear value is not considered, but I need to print this. Okay, but I'll print this with the rear label. Hence, I would like to have it outside the for loop. So print, and then, the Q, you could just come up with the rear. I hope, you got me, because we are done with the explanation already. So just aside to it, I'll have the label of rear. So this is important, indicating that this is the frontmost element, this is the rear element, the last element, right? Okay, I guess that's pretty much. I hope I have not made any mistakes, but like I said, it shouldn't be a problem if we had made some mistakes. We get this opportunity to debug. Okay, I better keep track of the time. Okay, now I'll just push this, and then we'll try to run the program. Okay, I'll just save it, and then we'll run it. It starts from here. Okay, and then press F5. Oh, it looks good. Okay, fingers crossed. This is just the beginning. Number 1. Okay, and then member number, let's say we'll keep it simple, 100. Member name A, age is, let's say, 15. All right, press enter, and then let's NQ or insert one more, 101 B, and then you have 16, right? Enter the choice again. Let's NQ for the one more, for the last time, and then you have 102, and then it's C, and then 17. All right, so we'll just display and check number 3. Oh, there you go. I think I got this right. So this is the first one that I inserted, 100A15. This is the second one, and this is the third one. So the front points to the first item that has been entered, and the rear points to the last item that has been entered. So this data structure is called as FIFO, first in, first out, which means this is the first one that got in, and this should be the first one, that should be out of the queue. So it should be FIFO, right? So let's check whether it stands true or not. So after displaying, let's DQ. So that's number 2. All right. So when I entered the choice as number 2, it says deleted item as none. So I've made a mistake, logical mistake. So this is not a syntactical error. So let's go and check, the deleted. All right. So I must have made a mistake here. Okay, there you go. I've made a big logical mistake, but we'll try to fix it. I should have item is equal to, I'm sure some of you must have noticed this. If you have noticed this mistake, which means you have really understood. Okay, but for us, it gives us a good opportunity to check for the error and how to fix the error. Right? So understandably, deleted item is none. So which means I am not returning any value from the function. So q.pop should be assigned to item, and then at the end of this, okay, I should write return item. So this is a serious mistakes. Okay, now let's do all over again. I need to do all over again. Let's come off the program, and then let's run this again, right? So run F5. Let's do it one more. 1A, oops, sorry, what's wrong with me? Okay, number 1, and then the member number, let's say 100, member name is A, age is 15. Okay, let's NQ another one, 101, and then member name is B, age is 16. Let's do one more, 102. Okay, member name is C, and then age is 17. Display was working all right, I guess. Now it's time for DQ, right? Number 2, hopefully it works. Okay, there you go. Deleted item is 100A15. So that's the first one that got into. So that will be the first one that should get out. Okay, so let's DQ another one more. So okay, 101 gets out, and then let's try to display display is number 3, is it? Okay, so this is the only element left, hence front and rear both point to the only remaining the element, the last element is the 102. All right, so 102 is the last element that got inserted, so that will be the last one that gets off. So first in, first out, last in, last out, something like this. And then we'll try to dequeue. Okay, number 2 deleted item is this. And then finally, when we try to dequeue again by pressing number 2, queue is empty. This situation is called under flow. All right, and then try to display by entering number 3. The queue is empty. All right, so I've made one mistake, so please take note of this. Okay, now we are done with 2 big programs. Okay, now let's check what do we have for number 3. Okay, number 3, it should be pretty simple. Okay, I'll just get this up. Okay, what does it say? Let's read it. Write a function in Python, insert queue, delete queue, for performing insertion and deletion operations in a queue. ARR is the list used for implementing queue, and data is the value to be inserted. So you're just being asked to write the function. So it will be something like this. Okay, just get this up. Okay, this is pretty straightforward. Sorry. Just make some spaces. Okay, that's better. Okay, so you are just being told to write the function definition for insert queue and delete queue, right? So you need to come up with a function definition like this. Def. Now this is not a full-fledged program, hence I'll not be able to show you the working of the program. Okay, so def. Now those 2 big programs should be more than enough, right? Def. Your answer should be like this: insert queue and then receive the list as ARR. Okay, and then say data is equal to get the data to be added onto the queue whose name is ARR. Okay, so get the data. So the data, let's say it's an integer, say input and then enter the value, something like this. Okay, and then you just need to add it to the queue, right? So it's very simple. ARR dot append. All right, and then you have the data, right? So this is the function definition for insert queue. This is little different. In the earlier examples, the data to be inserted comes from the main part of the program, and it's being received by the function definition, and then that's how the value gets appended. But here, as per the question, the data is being received inside the function definition of insert queue, and then it's being appended, right? So and then for the next function definition, which is delete queue. Now this is very much exam oriented question, right? So delete queue and then again ARR. First things first, check whether it's empty or not. If ARR is equal to empty list, print, you could say like, the queue is empty, it's an underflow situation. All right, it's simple. And then otherwise, just wondering why the cursor, okay, I missed out on this. Okay, so else, why don't you have a message first, print, because we want to do it here, right here, instead of, passing the values back to the main part of the program. Okay, so print, and then, the deleted item is, how about ARR of 0? I hope it makes sense to you. I just would like to, let the user know that the deleted item is ARR of 0. Since it's Q, the first element has to be deleted, right? And then once you print out the message, why don't you, get rid of it? Either you could use the pop or you can use the del function, right? If you remember correctly, in class 11 we have done this. Okay, so this is again another way out to remove or get rid of element in the list. Okay, so del, either you could say pop ARR dot pop 0, or you can use the function of del, right? So this is how you write the two function definition for this particular question. It's a very, very important question, very much exam oriented, right? Okay, now let's check out, the question number 4. Okay, so it should be a cakewalk, should be very simple. Okay, now let's go for question number 4. Says write a function in Python, make push and make package, make push and make pop to add a new package and delete a package from a list of package description, considering them to be act as push pop operation for the stack data structure. So again, come up with the function definition. The function definition is make push, okay, and then receive it as package. So let's not bother, whether it contains one element, two elements. We just have to assume that the list that, comes in is named as package. All right. So since it's not a full-fledged, question, you don't need to worry much about the entire program. Just focus on the function definition itself. So I need to push it. So how do you push it? First things first, I need to get the data first. Data. Okay, I want to, push integer value onto the package. So it could be, it says package description. All right. Package description means, it cannot be int. So it has to be string. So enter package, something like this, package description, right? Like I said, since it's not a full-fledged program, you can just get away with the details of the program. And then it's now time to push. All right. So where do we push it? The name of I think I got this right here, right? Okay. So the name of the stack to which I need to push is the package. So package dot append, and then you have the data, which is to be added. All right. So I hope it's pretty clear. So, once you do this, it's now time to, go for the next one. The make pop. So def make pop. Okay. And then you have the package. Okay. Like this. So for popping, you need to check whether the stack is empty or not. All right. So if package is equal to, empty list, then, print a message stack is empty. All right. Stack is empty, and then it's a situation of underflow. Okay. Like this. And then else, if the package is not empty, then, perhaps you could do it like this. It's pretty simple. We'll come up with a little variation. The popped item is, can I do it like this? A package, dot pop. How about this? So what happens here is, if the package is empty, you will understandably get this message, stack is empty. It's an underflow situation. All right. Otherwise, the popped item is, this pop function will remove the element from the package, and then it has to be assigned to a variable. But since I don't have a assignment variables, the returned value is being printed. So you have this assigned to a variable and print that variable, or you can just have this function directly included as a part of print statement. So package.pop will first, get rid of the element, and then, the returned or the popped element, will be printed. So in the earlier examples, we have assigned this to a variable called item. But here, as a matter of little variation, I've just straight away, printed the popped item, right? So through these two, the function definition, I'll be able to accomplish the function definition for make push and make pop. All right. So it's just that you need to take care of, the certain changes in the names. Otherwise, the crux of the matter will always remain as it is. Okay. So I hope, you have understood how to write the function definition for make push, make pop, insert Q, and delete Q. And then I request everybody to be prepared from examination point of view based on questions, the likes of questions like question number 3 and question number 4. Okay, now let's move on to, I'm running out of battery. I better check. I need to keep one eye on the battery of my iPhone. Okay, so propose a data structure. That's a question which is quite interesting, which I found it at the back end of your textbook. Propose a data structure which supports the stack push and pop operations, and a third operation find min, which returns the smallest element in the data structure. Okay, so this question is pretty interesting. First of all, I want you to understand the question. We need to implement the push and pop operation, and then another function find min. In the middle of pushing, popping, if I just call upon the find min operation, the program should be able to display or print the minimum value of the stack. Okay, so since the question is based on propose a data structure, so we just need to come up with the structure or the rules or the methods. We don't need to actually come up with the program. So in other words, the question is asking us the algorithm or the ways about doing it. So once you get the algorithm, it's fairly easy to move on into the programming aspect, right? So in order to, I hope you have understood the question. So let me take the help of this. Now let's say, now this is just an example, it's meant to understand the actual data structure that needs to be proposed, or the algorithm behind that very question. Algorithm means the logical sequence of steps, not exactly the program. So the idea is you have two stacks. The first one is S1, and then you have the S2. Now once I show you the operation, we'll then come up with the proposed data structure, or the rules, or the methods, or the algorithm. So and then the S1 is called main stack. The second one is called the supporting stack. All right, let's get the full. Okay, this is better. Okay, so it's going to be like this. I'll have to start from here, push. Okay, so this 50 will be pushed onto the main stack. So when I start with the first number, the first number will always be the minimum or the maximum. The reason is, it just, is the first and the only element in the stack. It's just like this. Let's say in the classroom, you have only one student. So during the result declaration, who tops, same that student, who's the last, again, that same student, right? Who goes out, he has to get, who comes in, he has to come in, right? So likewise, the supporting stack will maintain the current minimum value of the stack. I repeat, the supporting stack, which is S2, will store the minimum current value. Minimum current value means as per the current status of the stack, out of which the minimum value will be stored onto the supporting stack. So the methods will be like this. To start with, the first element will be pushed both to S1 as well as S2. So the 50 will be pushed to, the S1, okay, as well as S2. So since, I just have only one element, that element will be the current minimum value. Okay, hence I'm doing so. Now comes the next, push 40. Now there is a rule. When do you push the elements? Okay, when do you push the element to the S2 is if this value is less than the current minimum, then this value needs to be pushed on to the S2. I repeat, the next value to be pushed, will of course go to S1, but when will it be pushed on to supporting stack is if this value is less than the current minimum, which is 50. Like I said, supporting stack is used to maintain the current minimum value. So since this 40, it gets in here, it has to get in. So because this is the main stack, so this 40 will be pushed onto the supporting stack. The reason is it's less than the 50. So you have 40 here. Now 35. Okay, when will it be pushed if it's less than the current minimum or the topmost element, right? So you have the top here. Okay, top here. So this is how you do the comparison. The topmost element will have to be compared with 35. If 35 is less than 40, 35 will be pushed onto the supporting stack. So first it goes onto the main stack, and then will it be pushed onto S2? The answer is yes. So 35 here, and this top will point to 35. So likewise 55 will be pushed here, but will it be pushed onto S2? The answer is no, because this value is greater than 35. Okay, now it's getting simpler. What about 37? 37 will be pushed onto the main stack, but it will not be pushed onto S2 because this value is larger than 35, and this supporting stack is used to maintain the current minimum, right? So this 37 will not be pushed. And what about this 20? Yes. Okay, I just need to go a little back. Okay, no problem. Okay, so 20 will be pushed. Okay, 20 will be pushed onto, okay, main stack, and then 20 will be pushed onto S2. Now let's say after step number 6, I missed out on this, no problem. After this particular step, I want to call the function of getMin. When you want to, sorry, this will be updated. Okay, so when I want to get the minimum value, all I need to do is just, have a peek at the supporting stack of S2. So whenever I call this function, I just need to have a function definition which will let us have a peek at the topmost element of S2. So this 20, will be the minimum value of the elements of S1. Okay, I hope you have understood. So whenever I want to call the function of getMin, the function definition should be allowed to peek the S2. Peek means accessing the topmost element of the stack. So the topmost element is the 20. So 20 is the minimum value of the numbers which are pushed onto the main stack. And then, we have already learned how to, peek the element, how to gain access to the topmost element. It's pretty easy. Top is equal to length of S2 minus 1, and then S2, and then top, right? So that's something, which is to be noted. Now, let's say pop. Now, this is interesting. Now, say I have a pop operation. Now, when I pop, when do I pop? That is the question. When I pop, what happens? When I pop from here, okay, from S1, should I be popping from S2 as well? This is the question. Pop means you're talking about the S1. So this 20 will be popped. But this 20, if the value is equal to the topmost element of S2, if the value to be popped from the S1 is equal to the topmost element of S2, then, the topmost element of S2 should also be popped. Okay, I hope you got me right. I would like to repeat it one more time. Whenever you have a pop operation, it will be popped from the main stack for sure, but will it be popped from the top? You should check whether the values are equal. If the values are equal, then you should pop from S2 as well. Now, since I'm saying pop, this query should go, but this query is equal to the topmost element of S2. So which means, this will go for sure, but this will also, go, right? So the top will be decremented like this. Okay, I'm done with this. Now I have another pop, right? I have another pop. Now 37 needs to be popped. But again, should I be popping 35? The answer is no, because 37 is not equal to 35. So which means I'll pop this, but I will not pop this because 37 is not equal to 35. Now let's say after step number 8, I call upon the function of getMin. Now again, getMin is all about picking the S2, accessing the topmost element of the top. So the topmost element of the S2 is 35, and 35 is indeed the lowest value among these 4 elements of S1, right? So it's pretty simple. Now push 60. 60 needs to be pushed. Now we have 3 rules that need to be kept in our mind, okay, which I've covered already, but we'll just come up with the steps in the form of ticks. So where are we? Push 60, right? So 60 will be pushed, but since 60 is not less than 35, okay, 60 will not be pushed onto S2. And then you have again pop. I pop this, but when I pop this, should I be popping 35? The answer is no. So I just get rid of this. Push 10, I push 10, okay. Should I be pushing this to 35 to S2? The answer is yes, because this 10 is less than 35. So I push, okay. And then finally, let's say I run another find min. So this time, sorry, this will be updated, right? So when I find or call the function of find min, it's all about picking the S2, and then up on the top of the stack you have the 10, which is the minimum value among the values of these elements of S1, right? So all in all, I won't write it. If you could hear me out well and then write it on of your own, it'll be of more challenge to you. So the step number 1. So coming back to the question, step number 1 will be like this. The first element needs to be pushed onto S1 as well as S2. I repeat, first element, has to be pushed onto stack S1 as well as S2. Okay. Step number 2. When will the push happen? When will the push happen? When will push take place? The element, needs to be pushed onto S1. The element will be pushed to S2 if that element is less than the current minimum value of S2. Okay. Just understand me, hear me out well, understand, and then, just write it down. Once again, the first one is over. The first element has to be pushed onto stack S1 as well as stack S2. The second step is the element, when push will take place. The element, has to be pushed onto S1. It will be pushed onto S2 if it's less than the current minimum value which is stored in S2. If it's more than, it will not be pushed. If it's less, then it will be pushed onto S2. Now the third step is, when do you pop? The element has to be popped from the S1. That's obvious. The element will be popped from S2 if the value to be popped is equal to the topmost element of the S2. Or in other words, if the value, is equal to the current minimum value of the S2, then that element has to be popped from S2 as well. So that's step number 3. If I just repeat it, when will the pop take place? The element should be popped off the stack S1. It will be popped off from S2 if the value is equal to the current minimum value, or if it's equal to the topmost element. Okay, so that's it. It's pretty simple, right? Now let's move on to the final question of today's session. It's already 1:16. Okay, consider an empty stack of integers. All right, consider an empty stack of integers. Let the numbers 1, 2, 3, 4, 5, 6 be pushed onto this stack only in the order. So the order of the entry is like this: 1 will be pushed, followed by 2, 3, 4, 5, 6. This is the strict order in which the elements will be pushed, and then understandably they'll appear from left to right. So 1 gets in first, followed by 2, 3, 4, 5, 6. Let S indicates push, X indicates pop operation. Now the question is, S stands for pushing, X stands for popping. Can they be outputted in the order of 3, 2, 5, 6, 4, 1? That's the first question, and this is the second question. So, can these numbers be, displayed or outputted in this particular order? Okay, let's check. I hope you have understood the question. The way the numbers should go, it has to be like 1, 2, 3, 4, 5, 6. But with the push, with the combination of push and pop, with the combination of X and X, S and X, can we, output the number in this order? So let's switch to this. Okay. So this is the question. This is the question. All right. Just get this. Okay, how do I get this? Okay, I'll just get rid of the colors. Okay, look at this. Okay, let's say, this is the question. Can I output, these numbers in this particular order, 3, 2, 5, 6, 4, 1. All right, so let's check. Now the 3 is the first number to be displayed. All right, 3 is the first number to be displayed, right? So which means I need to push, 1, 2, 3, and then if I pop, I get the answer as 3. This is the first number in focus, right? Just mark this. Okay, so how do I get number 3? Straight and simple. I push 1, I push 2, I push 3, and then I pop, I get 3. Okay, so which means, remember, S is for push, remember? So I'll have S, so which means, 1 will be pushed, and then strictly in the order of 1, 2, 3, 4, 5, 6, right? So another push will push 2, another push will push 3, and then when I have X, when I have pop, this 3 will be popped. Okay, I get to output, the number 3, all right? I get to output number 3. So which means 3, will be the first output, all right? Now the next step is, I now need to, output 2. So 2 is the topmost element, right? So when I say X, what happens? This 2 will be popped, and then I could say like, I could display it. So I now got the correct order so far. I got 3 first, I got 2, all right? So I just have only one element. Now next is the 5 in line. So how do I get the output of 5? So 1, 2, 3, they all have been pushed, all right? Now you cannot again push 2 and 3 because the question says it needs to be in order strictly. So the next number that has to be pushed is 4. So what happens here is I say S, okay, so which means 4 will be pushed. Since I need to get 5, again I say push. So after 4, 5 will be pushed, all right? And then, if I say pop, this 5 will be popped off the stack, and then I could display 5 right after 3, 2, okay, and then I have the 5. All right, and now next up is the 6. It's very simple, 6. So I need to again push 6 because I have not pushed 6. Remember? So when I write, when I write S here, I managed to push 6. Okay, and then again I pop. When I pop this, 6 will be popped, and I could display 6 here. Understood? Okay, and then now it's time for this 4. All right, so this 4 could be popped. So I need to get this, right? I need to get this. So since 4 sits atop of the stack, if I say X, if I pop this 4 will be popped, and then it will appear in the output like this. And then finally I need to pop this, okay, and then again if I have a pop operation, this 1 will get off, and then I have this. Okay, so the final output is this. So the answer is, can you output in this fashion? Your answer should not just be yes or no. You should be able to come up with a combination of push and pop. So in order to print the final output of 325641 in a situation where the numbers strictly are being pushed in the order of 1 2 3 4 5 6, you have this as the combination of push and pop. And then finally, so perhaps you could try this. It should be pretty simple. Now the next question is, can they be outputted in the order of 1 5 4 6 2 3? If yes, you have to come up with a combination of push and pop. Otherwise, you need to reason, you need to justify why isn't that possible. All right, so these are some of the exam oriented questions. The first 2 are big, but since we have already learned it, it shouldn't be much of a cause of worry or concern to you. And then the later 4 questions are very much exam oriented, and then especially question number 3 and question number 4 have been a part of the last year board examination for the subject of computer science. All right, so with this I would like to wind up, right? And then I hope you have understood the lesson well. And then again, there are many more questions in the textbook. I thought of spending one more session on finishing as many questions of this particular chapter, so that it will not only give you a feel of review, you will also be enriched with a deeper knowledge concerning this very important chapter of data structure. So I'm going to do that in the next video, and then perhaps after that I'll be starting a new chapter. So until then, please take care and study hard. Thank you so much.